So yeah, this talk is about automation. It's about how to automate tasks in the Node.js world, and specifically about dependency management and package publishing. But before I'll go into that, I want to talk about some general principles about automation. Kill all humans. That's the title of this talk, and that's also Bender's favorite phrase. Of course, because he's a bot. He thinks bots are way smarter and way better than humans, and that humans will only ever bring bad to the world. And after recent events, I'm not so sure I would want to disagree here. So the question is, why would a robot like Bender believe he's better or smarter than a human? Let's take me, for example. My name is Stephan Bönnemann. I'm human, from Berlin, Germany, and I'm very happy to be here today. And there's a thing about me. Honestly, most of the things I do all day, they are super trivial. If you look at a typical day, showering, tying shoelaces, cycling, walking, eating, opening a laptop, typing, reading Twitter, even programming sometimes. All of these things are trivial. That doesn't mean that these things can't be exhausting or stressful, but usually there isn't that much thinking involved. And whenever this happens, whenever routine develops, things get dangerous. And I had to think of a very drastic example here. Earlier this year in Germany, there was a fatal railway accident. Between Munich and Salzburg, there is a single-track section where trains can still go in both directions. And so in order to prevent crashes, there's a train director sitting in a small hut nearby, and they have to manually press some buttons so the train drivers know whether they're good to go. And as it turned out, the train director was so bored by this that he just started playing smartphone games. And eventually one day, a mistake happened and two trains crashed into each other. He even realized this mistake, but then he pressed the wrong button, so not the train drivers were alarmed, but someone else. And that's really a tragedy. Or you can think of self-driving cars. Everyone is pretty excited about them, but as soon as we have them, the next logical step would be to forbid humans to drive cars, because we're just so bad at it. And computers could do a way better job, especially if there are no more humans on the road. And if you think about the trivial things we do all day, showering, cycling, walking, most of the accidents happen when we do just that. So humans are super bad at trivial things. And most of what we do is trivial. So I think it's rather obvious why a bot could believe that they're better than us. Because that's what bots are exceptionally well at, exceptionally good at. So once we taught them how to do something, they can repeat it over and over again. And they're faster at it than we are, they are more reliable at it than we are. And by this, they can reach a scale that makes things complex again, so that we couldn't even repeat it ourselves or could even understand it. But there's one thing that sets us apart, and that is that we are capable of taking hard decisions, of doing substantial things, of taking responsibility or applying ethics. So whenever we think there's a really hard problem, then we become very careful and considerate. We ask for help, for feedback, we have a second look. That makes us way better at solving hard problems. So with this in mind, I derived two principles for me whenever I want to automate something. First, I want to eliminate nasty, dull, and repetitive chores. And the second principle is that I try to enable humans to make decisions by providing them all the information they need so they can just focus on the decision with the least possible overhead. So with this little primer, let's get started. The first topic is dependency management. And with these two guiding principles, it's actually pretty simple to deconstruct it. So the first question is, what are the chores of dependency management? And this is just my list. Yours could be different or the same. We have to regularly check for new versions. We have to install them, and we have to run our tests for them when we like it. We have to find release notes, because we actually want to know what's changed in there, and sometimes they're on GitHub releases, sometimes they're in issues, sometimes they're on a website, sometimes they're not even there. And then, when we like it, we create a new commit, we have to push it, we make a pull request, someone has to merge it. And then there's the second question. What is it that we actually care about in dependencies? And especially when they update. What is new? Is it safe to update? And are there any breaking changes that are affecting me and that I need to adapt my code for? So enter Greenkeeper. It's the first tool I want to show you, and it aims to eliminate all these chores while providing you all the information to make a decision whether you want to update or not. And let's look at the underlying idea here. So here's a diagram. On the left, there's NPM. On the right, there's GitHub. And Greenkeeper is a service that just sits between those two. And so as soon as a change is happening in the NPM registry, Greenkeeper listens for that. And then we figure out if there's a new version of a dependency, we figure out who is depending on that dependency, and then we send a pull request to the project with the new update applied. And this is what it looks like. This is just a usual pull request. You can immediately see which dependency this is about, whether it's a dev dependency or a dependency, what the old version is. And if you scroll down a little, we provide you some more information. So you can unfold the release notes that we automatically pull from GitHub. Or if those aren't available, we also give you all the commits that happened since the last version. So with the pull request also automatically triggering your tests, you have all this information available. You know what's new, you know if there's a breaking change, and you see that your tests are still running. So it's pretty much just one click. There's pretty much no friction from just making the decision whether you want to update or not. So with this, it gets really, really easy to have your dependencies up to date. And this is really only great for out-of-range dependencies. So what does out-of-range mean? For example, here on the left, we have a version definition with this caret character, so it's caret 1.0.0. And when the version 2.0.0 comes out, it's outside of the currently defined version. So it makes sense to send a pull request for this. But if there are updates within this version, it wouldn't make sense to send a pull request because we're already implicitly depending on this version. And so what are we going to do? As I said, bots are exceptionally good at doing things over and over and over again, even at a scale that we wouldn't want to or could do. So there's version 1.0.1, 1.1.0, 1.1.1, all the way up to 1.1.99. It happens all the time. So what could we do about them? Let's go to the diagram again. So when there's a new version from NPM, we also figure out, is that version already inside of your current version definition? And if it's inside, we don't send you a pull request, we just create a branch. And branch creation kicks off your CI service. So we can then listen for the result of your tests and see when it failed and send you an issue. So this is what it looks like. Here's a module. It's inside of the version range we have defined. It broke your tests. We will let you know about this immediately. You can see whether it's a dependency, dev dependency. You have the release notes and the commits available. And we can even do more cool stuff here. So if you scroll down, you can see as soon as this happens, we just create another branch where we pin to the last version you were depending on. And if that is passing, we really know that like there's a problem with this specific version. So you can just click on downgrade this dependency. It will lead you to the interface to open a new pull request. You can merge it into your code base, and your build is passing again. And I think at this point, it's becoming obvious why we call it Greenkeeper. So again, what is it that we care about? What's new? Is it safe to update? And is there a breaking change that affects me? And Greenkeeper is really trying to provide you all that information, but we can also only provide information that package authors make available. So how can we make that available if we switch around from the consumer perspective to a publisher perspective? And again, let's just take our two principles. What are the chores of package publishing? Number one, we have to remember and decide to do it regularly. We have to make sure that the tests are actually passing in all environments and all the node versions out there. We have to write a useful changelog. We have to decide on the version number. And like when we push the code, like we shouldn't forget to do -- tags. That's happening all the time. So it's all these little things that we just make mistakes at all the time. And what is it that we actually care about when publishing packages? And I think it comes down to this one thing. We just want to build cool things. And while we're at it, it would also be cool to just not break stuff that's already out there. So how are we going to do this? Two ideas. Let's split up the decision making. So we don't want to decide on a release and then decide on the version number and the changelog and everything all at one point. And we want to split up the work of doing a release. So we don't have to go in and like write a release note for 10 minutes. We just split it up into really small chunks. And this is how we're going to do it. So whenever we apply a change to our code, we're already having a point where we're describing what we changed. But most of the time, people just write useless stuff there because it's this one additional annoying step. Like, stuff is working again. No one knows what it means, but whatever. Just, I need something. Or you could go even further, like, whatever. And this is just what we won't do anymore. Because here we can do small chunks of work, and we can make small decisions. Because we have the change that we apply to the code right at hand. So instead of doing git commit -m, we just type git commit, and it opens up the standard editor, which means we can suddenly write a lot of text. And if we apply a structure to this text that we're writing, we can put some metadata there. So for example, this is an example commit message where we write fix, which is the type of the change, then a scope in the braces, which is pencil, and then just the regular message. So in this case, it's a module about pencils, and the graphite is breaking when too much pressure is applied, and we just fix that. So we can just write it down. Or there's a new feature. So instead of fix, we write feat, and then our description for that. Or if we're actually breaking stuff, we can just declare the breaking change. So in the body of the commit message, we write breaking change, : and then the description of the breaking change. And you can do much more than this, and here's like the full structure. But really, fix, feature, and breaking change is what we need to care about. And if you're worried about this, and if you're worried about contributors getting this, there's also a really cool new feature on GitHub where you can just do commit, confirm, squash, and merge on a pull request. So someone did this nasty commit message here, and you can just fix it up. And with this, we can just generate release notes. This is what it looks like. This is just a random example. You can see there are different sections for bug fixes and features. They're grouped by the scope, and you can see the commit messages linked up, and if we just reference the issues, they would also show up there. So release notes, we no longer have to care about them because we split up the chunks into, the work into small chunks. And the second part of publishing a package is the version number. And in the Node world, we have a scheme for that that is called semantic versioning, or short SEMver. And with SEMver, every single point in the release number has a special meaning. So the one on the right is the patch number. So whenever we fix something, we just increase that. The one in the middle is the minor number. So if we add a new feature, we reset the patch and increase the minor number. And if we break something, we increase the major number and reset the other ones. And here's some other names for that. We could also just call them breaking versions, feature versions, and fixed versions. And I think you're already noticing something. That's exactly what we wrote for our changelog, and it's like already there. The data is already in there, so we don't need to decide on the version number. We can just derive it from the commits we have written. So now we have everything together that we need. So releases can just happen. And how? Here's how. So this time we have on the left us writing code. There's GitHub, there's Travis CI or any other CI service, and then there's NPM. So someone writes code, he likes it or they like it, pushes a new pull request on GitHub, it triggers the tests. The next person comes around, reviews the code. If they like it, if the commit message is nice, they just merge it to master. And on master, it triggers another run on the CI service, which then, depending on the commit message, triggers a new release. And what it does, it just looks at all the commits that happened since the last release, derives the release notes, uploads them to GitHub, and then publishes a new package to NPM. So what you can see is that all of a sudden, the things that we care about, writing code and reviewing code and collaborating with others, are on the left, and things we don't care about are on the right. They just fade away. And we no longer have to think about it, and most importantly, we cannot make mistakes anymore. The tool that does this is called semantic-release. And it's available on NPM, of course. There's documentation, and there's like a CLI to set it all up for you. But if we think about publishing packages and about dependency management as a whole, you can see that the two diagrams that I just showed you, they just connect, and they just close the feedback loop. So you can write code, it gets automatically published, it gets automatically distributed to humans again. So semantic release and Greenkeeper, they work really well together. And this is how you can get it for your repositories. If you read the abstract, it said like it will fit on one slide, so let's see how I'll do here. This is how it used to work. You install the semantic release CLI globally, and then from within your repository, you just call semantic release setup, and we'll ask you a few questions, taking care of uploading tokens to the CI service, etc. And for Greenkeeper, this is how it used to work with the CLI tool, but there's a new feature from GitHub that we migrated to, so now you just can do it all on the web. So you just go to git.io/up-to-date, which will bring you directly to the Greenkeeper integration, or you can go to our website where it's all linked up. So 3 commands, but if you have done this once, it's pretty cool because you can install with this new GitHub integrations, you can install a service onto an entire user or organization, which means it will also be enabled for future repositories. So for the second repository, you don't need to install anything, you just do semantic release CLI setup, and Greenkeeper is already running. So it's just this one command that you have to do to set it all up. And again, here's this diagram on the right. It's like getting really complicated. I left out most of the things because like we're already, like Greenkeeper is also going back to the CI to get the status and going back to GitHub to get release notes. So it's really complicated, but who cares? All we have to care about is writing code and reviewing code. And we can do this all together. We can like focus on what is important, we can focus on collaborating and shipping important, cool stuff. So I hope with this talk that I could show you how to automate most of the things that are involved with managing NPM packages, but also a little bit more about automation. So with this, we can focus on communication. And thanks to Sharon's talk, we know how important it is. And if you look around at this conference, there are even more tools, and they're coincidentally my favorite ones. Guillermo showed us Now yesterday, which applies the same principles to deploying. Felix, who just spoke, works at Slack, which puts communication at the core and center. Pharos wrote Standard, which is a style linter with 0 configuration. You just run it and it works, and you don't have to care about anything. Or later today, you'll see a talk about continuous security, which just applies the same principles for security. So with this talk, I want to encourage you to build more tools like these, to analyze your workflows, to eliminate the chores where things are getting dangerous, and to share them with us so we can all get way less miserable. So we can live peaceful together with robots, and thank you. I also want to thank you to the organizers for putting up this event, and the translators, because they're really not doing trivial work all day. Thank you.